thank you for the introduction. As Richard mentioned, I'm with the Barnes Group Advisors. For those of you who don't know us, I understand if you don't, we are a collection of additive manufacturing engineers and experts. We have 130 years worth of experience combined, and our goal is to help industrialize additive manufacturing. One thing that's very unique is that this gives us a perspective of the AM supply chain. And as you guys know, AM is moving very far away from just prototyping and tooling, and it's moving into production, which requires tying into certification and qualification activities. So part of what we're going to talk about today is not only the definitions of certification and qualification, because sometimes those get a little bit confused and mixed up, but we're also going to talk about the critical role of the machine developer in supporting their customers with the qualification process. So, in its most basic sense, it really doesn't matter what industry you're in, whether you're in aerospace or medical or oil and gas or any other industry, there's going to be some level of requirements for certification. Certification is when a component meets design intent, but it's also fit for service in a system. This is done by an independent authority, and so it's signed off and blessed to say that this component is good to go on an airplane, to go in oil and gas, to go on an automobile. The qualification process is a critical part that supports certification. This process not only needs to take care of the machine and the process and the material, but the entire manufacturing system to get to the point where you can certify a component. Oh, systems views out. So if we go through and we talk about certification pillars, Jack Lincoln's pioneering work in aircraft structures is a really good place to start. So we start with requirements and design criteria. So this, at its heart, is where most manufacturing processes start. What are the requirements of your process? At TBGA, we actually jokingly talk about that. We say requirements, requirements, requirements. So once you understand those, the first certification or pillar in certification is taking those and translating all of the information that you have and saying, okay, does this translate to the design intent and performance of that component in the system? The problem that we have right now with additive manufacturing, though, is it's not as mature as traditional manufacturing processes. Traditional manufacturing processes, the material process relationships are very well known, and the data has been around for quite a few years, as well as having components in service for a long time. So the confidence level for those processes are very high. Additive manufacturing, due to its less mature status, requires a lot more information from the certification authority to support that. These other pillars that we represent here is where the lines start to blur just a little bit between qualification and certification. It's in particular for the additive manufacturing process. So if we kind of walk through these, I mentioned requirements and design criteria. So that's going to be owned by the design owner. So often in this case would be a VELO3D customer. Stability, robustness, and repeatability are basically described as saying the first part, the last part, the middle part, they all are going to be essentially the same per the certification plan. Producibility is closely linked to that, but it has more of a geometric element. So for example, one part might be very producible and have a lot of stability on a machine, but when you switch geometries, do you still have that same producibility on the machine? And Zach's going to speak to that. Another definitely big area is characterized mechanical and physical properties. Obviously, we need to have databases and understand that. Due to the immaturity of the understanding of those relationships, we're still at a point of getting to have those large databases to base design on. The last one that once again is very closely related to the previous is predictability of performance. So this basically says whenever a designer calls out using an AM process, that they understand and can be assured that they're going to get the properties required for performance of that part. So classic would be, in metals would be MMPDS, S basis, A basis, B basis allowables. Once again, we're not quite at that point with AM, so a lot of us are doing part certifications, which is part qualification from a data standpoint, but we're moving towards that. point where we could do process qualifications. And I think what you'll see that Zach is presenting, there are some exciting areas that VELO3D is working in that help support these key pillars.
Thanks, Laura. So as Laura said, what I want to talk to you about today is how VELO3D can help with the qualification process. This is really an important thing for a machine manufacturer, for a technology vendor like VELO3D to be involved in, because we can do a lot to make life easier if we kind of focus on that from the beginning. When I look at the 4 pillars that Laura was presenting, the first one is producibility. And producibility is really something that VELO3D set out to address from the outset. When we were initially looking at producibility, it was around the question of whether or not you can make a certain geometry. And we set out with the intent to expand the geometries that were possible to be 3D printed. So there are far more geometries that are now 3D printable in metal because of VELO3D and how we've addressed producibility. This is really just one aspect of it though. Producibility of a single geometry is a good first step, but really when you get into the discussions around qualification and certification, the repeatability makes a big difference too. And one of the things about producibility that you have to consider is yield, right? So you have scrap rates, you have rework that have to happen as part of the producibility. And the way this is addressed most commonly in metal additive is if a geometry is kind of on the edge of being possible to print, you'll often over support it. You'll add enough supports that the part will print well the first time and will continue to print thereafter. So with our process, removing many of these supports, we're addressing some of the producibility issues by just expanding this geometric envelope and providing for a much wider range of printed parts. The other aspect of it is yield and scrappage. And if you had the opportunity to be here this morning with us when we were presenting with Stratasys Direct Manufacturing, one of the quotes from Stratasys that was a really good validation of our reduction of scrappage was when they said, when Andrew Carter from Stratasys Direct said, with the VELO3D system, we're able to produce parts with a much greater consistency and with far less build failures than we are with any other technology. So for us, that was a really good validation. It means that not only are we able to produce the part originally the first time, but to do this time and time again in a production setting. The second pillar that I want to address is around characterization. And I think in metal additive manufacturing, a lot of the materials have kind of a good initial characterization. And that's what we're showing here. This is essentially a study that looks at the average mechanical properties of Inconel 718 printed on our system. And this is a study that we did in conjunction with the Barnes Group advisors, where we were comparing this to castings and to wrought materials. And this is the kind of data sheet that in general you'll see at many of the machine manufacturers. This is a really good start, but it doesn't actually address all that you need to have a proper mechanical characterization. The other aspect of this that's really important is statistical mechanical characterization. So looking at how stable the mechanical properties are across a full data set. And in this case, we're presenting data from 5 different machines. So this is 10 different laser paths since we have a machine with 2 lasers. It's something like 100 samples and looking at how the statistics vary across the build plate, across builds, across machines, and across lasers. This is really important because it gives you confidence in what is really the third column that we're looking at, which is the stability, robustness, and repeatability. So here you can see we've put in our statistical bars. If you want a 3 sigma confidence level in your mechanical properties, this is essentially what you have to do. This means that 99.7% of the parts that we sampled were within the bands that we're showing here, well over ASTM spec. So definitely making good quality material. When we're talking a little bit more about the stability, robustness, and repeatability, I think it's important to kind of go a little bit further into the definition. And really, when you look at the definition, what you're looking at is, can I print the same part over and over while I'm varying the inputs and still get the same result? And the important thing here is varying the inputs. I think this is not taken into enough consideration when you're looking at the stability, robustness, and repeatability. And the reason I say that is that with many metal laser powder bed systems, when you start a print, you don't necessarily know the state of the machine. So you have a complicated optical system, and it's timely to calibrate in general. A lot of times this requires a field service engineer to come and do hours, if not days of work, and this is something that's performed on a PM interval. So it's every 3 months or every 6 months. In the time in between, you don't really know what's going on. So one of the things that VELO set out to address through our metrology was the ability to do calibrations in situ and to do them before every build from a single button click interface. So when you are starting a build on a VELO3D Sapphire, you open up the GUI and you say, calibrate optics. There's no external equipment required, and the machine basically runs through a set of tests that give you confidence that your machine is in a good state when you start the build. So we're doing this for, as you can see here, thermal lensing is our first metric, laser alignment, the sensor that we're using to actually calibrate all of these different metrologies, the laser focus everywhere on the build plate, and the powder bed stability. So it's a very complete characterization of the system before every build. That's a good first step, but the other thing that you really have to do is establish control limits for these calibrations. So you want to know that your calibrations are maintained within a certain spec, and that you have a spec that you can feel confident in that's coming from us, from the machine manufacturer. And so VELO3D has put a lot of work into establishing these control limits such that if your machine, after your pre-build calibration, says that it's within your control limits, you're in a good state to start printing high quality parts. So we do that not only with the pre-build calibration, but also with the execution of the build. Another thing that you'll notice is our heat map. And this is something that we can give a live demo of over here if you're interested after the presentation, where we're essentially documenting the entire build and showing what's going on in the build in a kind of easily digestible, what we call a heat map. And this gives you all of the build execution data with similar control limits. We have warning thresholds and error thresholds so that the build will send you an email or it will pause itself if things get out of hand. And then the final column really comes down to predictability of performance. So predictability of performance is knowing that the part that you get out of the machine is probably good, right? It's a probabilistic interpretation. And the trick here is it's kind of the holy grail of what metal additive manufacturing has been looking for the last 10 years. I want to know that the part that I pull off of my machine is good. And all of the machines that you'll see at this show are capable of making good parts. I think that's something that we really want to emphasize. They're high quality systems capable of making good parts, but the thing that's important is this part good? This part that I just pulled off, is it good? And that's a very difficult question to answer. So one of the things that VELO3D has been really focused on is making metrics that have a direct correlation to probability of porosity. So we're able to actually correlate the metrology that we're taking live during the print to porosity. And porosity is one of the main causes of defects and of poor mechanical properties that you see in metal additive manufacturing prints. So with this, we feel like we've given our customers a much bigger step towards qualification. We've made the path to qualification and certification a lot easier. Which is something that all metal AM manufacturers should really be doing for their customers. With that said, this is only a subset of what's required for the qualification of a part. And with that, I'll turn it back over to Laura to finish out what's required.
Yeah, before I go into the the qualification conversation, one thing that I thought was so unique about VELO3D's approach. You know, right now they're coming out with a particular software. Basically what they're doing is they're just harnessing the metrology that they already built into their machines during the development process. So a lot of times what we're seeing is machine manufacturers are having to kind of do a post-mortem and say, I need to understand more, I need to generate more data, and we're putting new sensors on. But I thought it was interesting how easy it is for them to then go and take that next step with the customer, because not only have they gathered that data for themselves, but now they're creating the software and the platforms to go and do that for their customer, which is obviously going to really, really help the qualification and the eventual certifications path to have that knowledge. So if we speak to qualification, so at this point, we're talking at a supplier level. So the highest level from a qualification standpoint is a facility. and that would be a supplier by supplier standpoint. And these are going to be things, if you require AS 9100 for aerospace, maybe it's ISO, for general manufacturing, it's going to be SPC controls, all of which we've heard there's some support for that. Then you take it down to the next level. Now you've got your machine and your process. You're going to need to qualify your different machines. You're going to have calibration plans for them. You're going to have to figure out all of that and have that locked down to be able to go and produce those parts to be on a certified application. At the very lowest level is we have the part. And within the part, often this is, print a few parts and make sure that things are good. But when you go beyond that and you go, okay, now I'm going into lot acceptance in production. We as a community are still struggling with what the right data package is for lot acceptance. We have reams and reams of data, but then we need to get it down to what are the 10 pieces of data that I really need that give me the confidence that that part actually meets the certification data that I did whenever I first certified the part. I feel like VELO's on that path. So today, we had demonstration, we've seen what they're doing in their data package. I think that's great. But one of the things that I'm really excited about that'll definitely be something that's a tomorrow activity is that linkage and the algorithms that predict things like porosity. If we get to a point where you can statistically say, I am comfortable, I've looked at my melt pool, and I know I have a good part, that eventually is going to hit some of those barriers for NDE and some of those other costs that we're doing because we don't have the confidence in the process today. So that's what we had for today. We're happy to take some questions, and we really appreciate you guys all coming by. Ooh, his question is, how much do we think we can shorten the qualification and certification time with access to basically better data? I would say from my standpoint, developing that data, in particular, just starting with even having enough material and process data to start the design process and feel confident there. So I feel like you have the opportunity to basically shorten and decrease. I don't know if I can do a percentage at this point. Yeah, but I mean, I would say once you have those known data pools and you have a known process, the hardest thing is to certify a component the first time with a new process. So once you've got that point and then you've got these layers and layers and layers of data, I think that we'll start moving really, really quickly. I think the point where we'll move really quickly is if we get to the point where we have enough data that we're confident to do it on a process qualification standpoint, at least for maybe a family of parts. I think that's a really, really good next step. And something like that could shorten the process by 50% or more. So the question is, in the aerospace industry, if we're seeing more time spent in certification or qualification. My answer absolutely is in qualification. However, they want to spend more time in certification and moving to that. So it's the high-level map of what certification looks like, and then there's all the qualification activities that stack up to that. The other thing is getting those maps in the first place. So there's activities starting to get to that point. But again, developing that data and that confidence, because you need to have a stable process before you go and create a whole bunch of mechanical property data, for example. So what we're seeing right now is often people buy a machine. They are ready to go to the races. They're ready to go and do their data and their allowables. And then they realize their process is not yet in control to the point that they need to. And so there's a lot of time spent in process development and that robustness and stability often before they can progress to the next step. So I think whether it's VELO3D or any of the suppliers, when you are helping your customers with that, you already have the process stability and maybe you have a level of characterized properties, they're much further off to the races in their activities. And hopefully that will then start pushing more of those activities into finally, getting the certified components in the more critical applications.
Thanks a lot.
Enjoy the show.